In this video, we'll answer 5 questions about coffee reviews, roasts, prices, and ratings with a real-world dataset, all using Python. Hello, my name is Thomas from Pyginners, and my mission is to help starters extract value by analyzing data with Python. The coffee dataset we'll be analyzing is sourced from Kaggle, which is a big data science platform, and you will find the link in the description of the video. The dataset contains detailed information about reviews, including attributes like coffee names, roasters, roast types, origin countries, prices, and textual reviews. These reviews come from coffee consumers who rate different coffees based on their experience. We'll be using this dataset to answer 5 key questions, and in this way, you'll learn with a hands-on approach how to gain value from data. If you're excited to analyze data with Python in order to gain value from data, you're at the right place. Make sure to subscribe to my channel so you're not missing any of my future videos. Alright, let's brew up some insights. Alright, before tackling our 5 questions about the coffee data, let's import the libraries needed for our analysis. Libraries are like toolboxes that come with pre-built functions. Alright, first step is to load in our data. I'll type in df equals pandas.readcsv, and the name of our file is simplified coffee.csv. And if we run this and the next cell df.head, we'll see our first 5 rows of the data. There's the name of the coffee, the name of the roaster, the roast type, whether this be medium light, light, or medium, the location country, that's the country of the roaster, the origin where the coffee is actually coming from, the price per 100 grams in US dollars, rating ranging from 0 to 100 max, and a review of the expert plus the review date. Also, I like to run df.info for a data frame in order to see how many rows there are and also of which type each column is. So here we have many objects, and the rating is a integer here, and the price is a float object. Question number 1. How do coffee ratings vary by the type of roast? In order to answer this question, we are going to create a new data frame called df_grouped, where we'll group by our data based on the roast type, and rating is the number that we want to group the data by. And we'll use the median value. The median value is the number that's exactly in the middle if you sort all values of a column. And I'll also add reset index to get a new data frame back. With backslash we can type on the next line, and I'm going to sort values based on the rating, ascending equaling false, so we'll get the highest rankings at the top. So if I execute df_grouped, we'll see that light roasted coffees have the best rating with 94, followed by medium, and at the very end we see dark roasting with 90. We can also create a bar plot with this, and the x-axis should be roast type, y-axis the rating, and for the coloring I choose palette equaling flare. We'll set a title, median coffee ratings by roast type, and plt.show. Great, we'll see our bar chart with light having the best rating, going from ascending to descending, with dark roasting at the very end. Question number 2, is there a correlation between price and rating? So we want to find out the correlation between price and rating. In order to do that, we can make use of the pandas core function, which calculates the correlation between numerical values. And here we want to have a look at the price and the rating. So I filtered to just these two columns and added .core. If we run this cell, we see that obviously between price and rating there's 100% correlation, and we're interested in this number. 0.24 is the correlation between the price and rating. And if we wish to label the strengths of the correlation for absolute value, 0.24 is regarded as rather weak correlation, and a strong correlation would be something above 0.6 up to 1 as a very strong correlation. Another way to have a look at this is if we do a scatter plot by plotting the price and the rating. And we can also add a reg plot on top of it. That's a regression line, meaning we can also see the regression on the chart as well. If I execute this, we see the price on the x-axis, on the y-axis the rating, and our regression line here. We can see if there was a high correlation between rating and price, we would see more dots here on a linear line going from low price and low ratings up to high price and high ratings. But we have many points here on the left side of our chart which are rather cheap and still have a good rating. Question number 3. What is the distribution of ratings across coffee brands? Okay, if we look at our initial data frame, we can see that we have the roaster name in the column roaster. And if we type in df.roaster.value counts, we can see that there are 300 different roasters in total. So in order to make a meaningful statement about this question, I'm going to focus on the top 3 roasters: Kakalov, Cafe, JBC, Coffee Roasters, and Paradise Roasters. So I'm going to create a new data frame called main roasters, which is value counts as before, preset index, query, and only the ones with at least a count of 80. And these are our main roasters. So if I execute this cell and this cell, we'll get an array, a list of the 3 coffee roaster names that we're interested in. Now, in order to see how the distribution of the ratings looks across these 3 brands, I'm going to use a KDE plot, and that's a kernel density estimate plot, which is a method for visualizing the distribution of observations in a data set, similar to a histogram. However, a kernel density estimate plot represents the data using a continuous probability density curve in one or more dimensions. And I like it especially if it's great to compare the distribution of multiple values, and in this context, the different coffee roasters. So the data is our df, and we're going to limit on the roasters that are in our main roasters array, and we'll use the .isin function, and on the x-axis we're going to see the rating, and the different colors will be represented by the different roasters. So, all right, let's have a look at this. And here we can now see the distribution of the ratings of the 3 main brands, and we can see that JBC Coffee Roasters overall has the lowest ratings, and the peak here in orange comes from Kakalove Cafe, which has the highest ratings here, a little bit over 95, and Paradise Roasters is a little bit in between of the other two, with the peak at 94 rating. Question number 4, which countries produce the best coffee? In order to answer question number 4, we'll use the group by function, and this time we're going to group the data by origin country, and the rating is the column that we want to use in order to aggregate. So not only do we want to get the mean rating, we'll also include a count, so that we can filter for countries that have at least 10 reviews in our data. So I'm going to add the query function here and indicate count bigger or equal than 10, and I'm going to sort the values by mean with the highest values at the top. So our DF origin will look like this. Panama is the first row with a mean rating of 94.5, and it has 70 reviews. And the next one is Kenya, 93.87, and so on. So we see many high ratings above 90 in our DF origin. Again, I'm going to hear a bar plot here because it's great for our intention here to display the top countries regarding rating. So I'm going to set the fixed size to 18 and 7. X-axis will be origin of our DF origin, which is data. I'm going to add this here to make it clear. So data is DF origin, X-axis the origin country, Y is the mean, and palette will be flare. In order to make it visually more clear, I'm going to set the PLT YLim to 80 up to 100. So because all of these values are at least 92, so that makes it better to look at. Another helpful advice is that you can set the X ticks, which are the countries here, to a rotation. I think it's better to read, so I chose to have rotation 45 here. All right, we can see Panama here, followed by Kenya in our bar plot. Question number 5, what are the most frequent keywords in the reviews of the highest rated coffees? All right, let's tackle this question step by step. So we're only interested in the highest rated coffees, so I'm going to limit to ratings that are above 95. So I'm going to rate a new data frame called high rated, and df, our initial data frame, followed by square brackets, and in the square brackets the requirement, in this case the ratings that are very high. So high rated will look like this. We have only ratings with at least 95 left, which is perfect. Next step, we're going to use the count vectorizer in order to count the keywords in the review column. So first of all, we're going to initialize the vectorizer, and the stop words, these are words that are like and the and so on, which have no real meaning to us. I'm going to specify the language to English, so yeah, I'm going to define it as vectorizer. And then next line is the fit transform method is used on the reviews column to convert each review into a matrix of word counts. Next, this line sums up how many times each word appears across all reviews in the matrix. Next, we're going to define words frag. Here we create a list of tuples where each tuple contains a word and its frequency of occurrence. The vocabulary and index of each word are retrieved from vectorizer.vocabulary. And this line eventually is going to sort the list of words by how often they appear in descending order from most frequent to least. And eventually we have our top keywords, and this contains a data frame of the top 10 words that appear in the reviews. All right, I'm going to execute all cells. And now let's have a look at top keywords. Good, we're seeing that cup is the most frequent word with a count of 70, followed by aroma and finish, mouthfeel, sweet, toned, all good attributes that describe a good coffee. We successfully answered the 5 questions about the dataset. I hope you liked this kind of data analysis about the coffee dataset, and let me know how you like this kind of format, and in the comments please leave me a comment if there is another question that you would like to get answered about this data, or if you missed any part, please let me know. I'm always interested in understanding how you like this video. So thank you and see you in the next one. Bye bye.